So in this lesson, we are going to interpret proportional relationships. We're going to be using tables, two variable equations, and graphs. Learning target is that you can apply your knowledge of proportional relationships that are organized in tables or as two variable equations or as a graph so that you can interpret those relationships. You'll know you've got it when you score at least an 85% or better on the assignment over this lesson. Okay, so we're going to use the graph of the proportional relationship to write a two variable equation and fill in the table. Margot is traveling on a family vacation across the country. Use the given information to fill in the missing representations. So we're looking at our, we don't have a verbal description. Remember, the verbal description gives us some kind of rate, typically a unit rate, so that we can start piecing our table together and our equations together. And they didn't give us the equation either. And then I go to the table and they didn't give us any kind of rate in the table for any of these hours they gave us. So I have to go over to this graph. And the graph has information on it. So I'm looking at the graph and I'm reading the ordered pairs. So this one right here at the bottom is 0, 0. So I can fill that in on my table. It's the ordered pair 0, 0. This is the ordered pair 50 and 1. Remember, we have to pay attention to our labels. So this is Margot's. I'm going to put that at the top. You can title it. This is her family trip. Margot's trip. We'll just keep it kind of short. I guess Margot has a T in her name. Margot's trip. So that is going to be the title of the graph. And it's telling us how many hours she drove and how many miles she got. So when I'm looking at this, I'm seeing that after 1 hour, she got 50 miles. And that's also in our chart. So I'm going to come over and write that in. After 1 hour, she traveled 50 miles. And that is a unit rate. So I'm just going to make note that the unit rate, I'm going to abbreviate unit rate, UR, is 50 miles. I'm going to put the units on it per 1 hour. Per 1 hour. That's a key number for our equations and our descriptions. So we've gotten some leeway now. I'm going to continue to look at these ordered pairs and fill out my chart. If she travels 50 miles in 1 hour, then after 2 hours, she's doubled her distance. She's gone 100. 50 times 2. So I'm going to write that in there. She's doubled her distance of 50. Then check the graph after 3. Yep, she's tripled her distance. After 3 hours, she's tripled 50. 50, 50, 50 shows us that she's at 150 here. And then 4 hours, she's at 200. That's quadrupling 50. 50 times 4 is that 200. So I can continue to read these off the graph, and they just go up by 50 every time I gain another hour. And these are all going in order. So I'm just going to be able to count up by 50, but I'm also thinking of it as the number of hours times that consistent amount every hour 50 to generate these as well. And I'm just checking with the graph to make sure. 5 was 250. 6 is 300. And indeed, 6 times 50 is also 300. And then looking at the graph, 7 is 350, which is what we expected it to be, because they're traveling at a consistent rate of speed, a constant rate of speed. And then our unit rate is just 1 times 50. And if they don't go anywhere, they don't spend any time on the road, it's 0 times 50. So we can use, the only piece they gave us that we could use to try to start building things was this graph. And once we figured out the graph, and we got some data in our table, we could figure out the process. To figure out miles, to determine the miles using the hours. To find the miles, we have to multiply the hours by what? The unit rate 50. So that is our multiplier, and hours is going to be H and miles M. So we'll use H and M for our equations. Okay, so remember, we always start with the M. We always want to start with that second column because that's what we're trying to find using H. So we have M equals something times H, and that something is the unit rate, 50. M equals 50H. And the word description for that is that Margot's family travels 50 miles every hour. It's that unit rate in word form. That's the description. They gave us this, we could have found the equation, the table, and made the graph. But they didn't. If they gave us the equation, we could have said, hey, here's our unit rate, and gotten this verbal description, 50 miles an hour, and then created a table from it and made the graph. If they gave us the table filled out, we could have figured out the unit rate looking at the table, and then graphed these as ordered pairs, and then we could have used that unit rate from the table to get our equation and our description. So we just need one of these 4 pieces of information to fill out the other 3. So the unit rate is key to all 4 parts because it starts the whole process off and tells the story of what's going to follow. Okay, I am going to have to scroll a bit to look back and forth to see the charts as needed to answer these. It says use the representations in the example above to answer 1 through 4. So the first question says, what is the rate in miles to hours? And then include the units on your rate. Well, I don't need to look up for that because we got it several times. Remember, the rate was 50 miles per hour. I'm using the unit rate for that. I am going to scroll up real quick. There are several rates. They have 100 miles to 2 hours, 150 miles to 3 hours. But when I reduce them all to lowest terms, they all reduce to 50 miles to 1 hour because they're all equivalent. Okay. How many hours does it take to travel 300 miles? Well, I'm going to look here and see the various places I can find this out. Looking at the chart, I can find that information out at my table because I can find 300 miles and it's right here and it tells me that took 6 hours. I could go to my graph and find 300 miles. It's right here and that tells me it took 6 hours. Or I could come over here and say, hey, 300 miles equals 50H. And then I have to figure out what do I multiply to 50 to get 300, and the answer is 6. So that would show me 6 hours. So I can use any 3 of these 3 pieces in the representation here to find my answer. Just depends on where you want to look, and it could be any of these 3 places. This one would require the most work because we already have the answer here. You just look it up. We already have the answer on the graph. You just look it up. This one you would need to divide 300 by 50 to get it. So it would require a little bit of extra work. But all are good sources to find your answer. So the answer is 6 hours. Okay. Now we got, if a family continues driving at that rate, 50 miles every hour, then how many miles would they have to travel, would they have traveled in 17 hours? So I go up and I look and I say, hey, my table doesn't go up to 17, so I can't just find it on the table. My graph doesn't go up to 17, so I can't really use the graph unless I extend it. So I'm going to go to the equation. The equation is open-ended. It says, hey, whatever hours you want to put in here, that'll give you the miles you traveled. So I'm going to use that formula. And I'm going to go M equals, it's 50 times H, and H here is 17. So I'm going to multiply 50 times 17, and I get M equals, you throw that into your calculator, and you should get 850, it says to include units, miles. So if they travel 17 hours on the road, they would have gotten a distance of 850 miles. Okay, the next question says, hey, what does the ordered pair 4-200 represent? Remember that 4 is hours on our table. It's the X, it's the first column, and then 200 is miles on our table. It's the second column. It says to answer in a complete sentence. So I would start by just rephrasing the question. the ordered pair for 200 represents that Margot family, remember we're talking about a trip, Margot's family will travel 200 miles every 4 hours. You just write it as a rate based on the H is hours, M is miles. So the ordered pair for 200 represents that Margot's family will travel 200 miles every 4 hours. Notice that I started with a capital, I spelled my words correctly, and I ended with a period. So complete sentence is going to be required and make your language arts teacher proud. Okay, this problem says, using the ratio 7 to 5, complete the table below and graph your values, then answer the questions. Okay, so I have that my x is 7 and my y is 5. So x is 7, y is 5. So I'm just going to put that in my table. And then I'm going to scale them up because I'm creating an equivalent ratio table. That's an equivalent or a proportional table, that all the fractions in this table are going to be equivalent because they're all going to be based on the start of 7 to 5. So I'm going to double 7. And if I double 7 to keep it equal, I also have to double 5. Okay, my next one, I'm just going to go in order. I'm going to triple. So I'm going to triple 7. 7 times 3 is 21, and then I'm going to triple 5 to keep it equal. 5 times 3 is 15. Then I'm going to multiply 7 times 4 for 28, and 5 times 4 for 20. And then finally, 7 times 5 is 35, and 5 times 5 is 25. So this ratio is saying every time you throw 7 more into the top, you got to throw 5 more into the bottom to keep the ratio equal. So 7/5 equals 14/10 equals 21/15 equals 28/20 equals 35/25. All equivalent fractions that when you reduce them, you always get 7/5, which makes this a proportional table. So using the information above, set up and solve a proportion. Oh, let's graph it first. They said first complete the table and then graph the values. Now, when I graph it, I'm looking at my x values and they run from 7 to 35. Actually, they run from 0, 0. Remember, that's always where proportional graphs start. 0, 0. And then they got to reach 35. So I'm looking at the x-axis down here saying, yeah, I don't have 35 tick marks. So I'm not going to count by ones. What would be a good number to count by down here that would be easy to work with? I'm thinking if I count by 7s and I just do that, this will be an easy grid to work with down here. So I'm going to use the 7 down here to count by, but I'm not going to mark every tick mark because I don't have enough room. It's going to get really crowded. So what we do a lot is we just skip. So I go 7 and then 14, and I just mark every other tick mark, but my scale is 7 because it's from 0 to here is 7, from 7 to 14 is 7. Now from 14 up 7 is 21, but I'm not going to write it there. I'm going to skip that because it's going to get crowded. 21 to my next tick mark, it's my 4th one over. That's 28. Then I'm going to skip this, which is 35, and get to this one, which is 42. And we're writing nice and neat so we can read our numbers. Skip 49 and mark 56. Skip 63 and go to 70. So we're skipping counting by 7s. Our scale on the X is 7s, but we're only writing every other one in. Now I look at my y and it starts at 0 and it runs to 25. Well, I don't have 25. What would be a good number to count by? Well, I'm skippy counting by 5s here, so 5 would be a really good number to count by. So 5, I'm going to also, just like I did for my x, I'm not going to mark every single one because it's going to get crowded. So this is 5, and then I'm going to mark the 10. 15, 20. My interval is 5s, but I'm counting and I'm just marking every other one. 25, 30. 3540, 4550. So I've marked my numbers nice and neat. And now we can go ahead and plot our ordered pairs. Remember, our ordered pairs are simply the X, Y. They're written on top of each other this way, 7, 5. So I'm just going to do 7, 5 would be right here. 14, 10 would be right here. And then 21 is this unmarked. And 15 is also unmarked, but they're right there. 28, 20, easy to spot because I have them marked. This is in between. 35, 25, and that's the last one I've had to graph. And as you can see, as we should expect, what I've been telling you is these proportional equivalent ratio tables start at 0, 0, and they run in a straight, not so straight, that was pretty. Let's get my line tool. They run in a straight line, and they do keep on going. Even though our table stops, this data can keep on going because we can keep going out, creating infinitely many equivalent fractions for 7/5. Okay, the next question asks, using the information above, set up and solve a proportion to determine the value of y when x is 49. So we're just going to go x over y. It's already set up kind of like that in the table. It's right here. You can pick any of these you want. I suggest we just use the one that's in lowest terms, the one we started with. So it's 7 over 5. And we want to write a proportion to figure out what y is when x is 49. And we have a few ways we've done this. We've done scale up or scale down, and we've also done circle, circle, and solve. In this one, I think all we need to do is scale up. Shouldn't have to work that hard with circle, circle. Okay, but if you don't see it, then do the circle, circle, solve. Okay, cross products and algebra. All right, so here I'm looking at 7 and I'm saying, hey, we're going up. It's getting from 7 up to 49. And 7 divides evenly into 49 7 times. So I know I just have to scale that up by 7 to get to that 49. And so I'm also going to scale the bottom up by 7. And you get 35. So you're done. If you see what to scale it by, go for it. It's probably faster than the cross products and algebra. But if you don't see it, then circle, circle, and then use algebra to finish it up. All right, in the next problems, it's use your knowledge of ratios to answer the questions below. The relationship between the number of hours traveled and the number of miles traveled on a family road trip is graphed below. Okay, so here is our picture. They've labeled this axis hours, and the miles traveled is on this vertical axis. So we're just going to use the graph to try to answer these prompts. It says, what is the rate in miles to hours? Well, when we look up here, they didn't give us the rate. We have to get it from the graph. So we're going to go to the graph. We're going to look at some of these ordered pairs. And I'm looking at my first one. It's 1 in 50. So right there I have, hey, in 1 hour, they traveled 50 miles. So the rate miles to hours, we could say is 50 to 1. This is miles, so it would go on top because it's mentioned first. And then hours in the bottom. So we could say 50 miles to 1 hour. Okay, someone might have said, well, I'm looking at this one right here, and it's 6 hours, and it took 300 miles took 6 hours. So someone might have said, hey, I see 300 miles in 6 hours. You could pick any ordered pair you want because they're all equivalent, right? The key is, at the end of the day, that no matter which two you pick, 4 to 200, okay? 3 to 150, no matter what, any of these that you pick to start your rate off, all reduce to simplest form 50 to 1. So if they have the unit rate on there, you're done. If they don't, you may have to take an additional step and reduce it down to the unit rate. So it's 50 miles per hour. That is the rate that they're traveling at. How many miles could the family travel in 12 hours? Okay, so from this graph, we have a couple things we can do. We can keep the rates going as a proportion. So it's 50 to 1. And they want to know how many miles in 12 hours, and you can solve that rate problem. Or you could, from this graph, recognize that, hey, 50 is the unit rate. So if I want to find the miles, I'll take 50 times the number of hours they're traveling to figure out the miles they got. And then it would just be simply m equals 50 times 12. And 50 times 12 comes out to be 600 miles. That's how far they'll get in 12 hours. Here, if you circle, oh, you're going to multiply 50 times 12 when you do it that way too. So we may do it differently because there's different ways to approach it, but we should all end up with the same answer. Okay, this one says, how many hours will it take the family to travel 700 miles? Again, when you're looking at this, we could do the miles to hours proportion, 50 to 1, equals, now we know the miles, they want to know the time, 700 over h, or you could come over to this equation again, and it's m equals 50h, and think about how this one would work. You know 700 this time, and you'd have to find h. Okay, so going this way, if we circle, we get 50h equals 700. Oh, we're not done, right? We got to divide by 50 on both sides. And we end up with h equals 14 hours. So we can use that cross products in algebra. I'm going to do the circle, just so you see what we did there. Because you can just set it up using your abbreviated word form like we've been practicing. On this one, we just plugged in what we knew. We knew m, but we have to find h. And guess what? You're right here again. They all kind of overlap, these strategies. And then you get the 14 equals 14 hours equals h. So that just a lot of proportional thinking, a lot of creativity using what we've learned through this unit to apply it here and answer these prompts, interpret this graph and be able to answer these kinds of questions using this proportional thinking. All right, we're going to start this one together and then let you work on your own, and then you'll check with the video to see if you got it right. So let's just start it together. The relationship between the number of bread loaves and the cost of these loaves is shown in the ratio table below. Graph the ratio and then answer the question. So we're going to graph it first just to see what the pattern looks like. See if we have an equivalent ratio table. We'll know if it goes through 0, 0 and it forms that straight line, we'll know this is an equivalent ratio table. And we'll be able to use that information to help us answer those prompts. So I want you to graph these ordered pairs on this graph here. And then when you're done graphing those ordered pairs, turn the video back on to see if you did it correctly. Okay, so here's my graph. Take a look at your graph. What you should have found was that these points here fall in that straight linear pattern. And if I continue that pattern down to the start here, it hits 0, 0. So all proportional graphs, these are equivalent fractions. They will look like a straight line running through 0, 0. So if you have that graph correctly, then you can go on to the questions. That's next. So the two questions you need to answer are how much would 12 loaves of bread cost? Include your units on your answer when you're done. And if Annie had $47.50, how many loaves of bread could she buy? And so I want to see what you did work-wise for each of these. So if you're using a calculator, tell me what you're putting in your calculator. If you're using a proportion, set up the proportion and show me how you're solving it. So whatever method you're using, you need to be showing me for each of these to make sure that you have it going on correctly. All right, pause the video and give it a whirl. Okay, so we may not have solved it exactly the same method, but this is what I did to get my answer. I first set up I just used the order of the table here and set it up loaves to dollars, 2 to 5. I used that reduced fraction form. And then I said, hey, I know that 2 to every 5, so I need 12 loaves. And how much will that cost? And I know that to get from two loaves to 12 loaves, I'm going to multiply by 6. So I multiplied 5 by 6 and I got $30. So 12 loaves of bread would run $30. My next one, if Annie has $47.50, that's how much money she has. How many loaves can she buy? I set up the same exact start. I use that reduced fraction unit right there. And then I put loaves over 47.50 because I need to find how many loaves would be 47.50. And then I looked at that and went, oh, I'm not sure what to multiply 5 by to get that 47.50 easily. So I'll just do circle, circle. And that led me to 5L equals 95. And to get L by itself, I just divided both sides by 5. And that gave me 19 loaves of bread. So if I had $47.50 is what I spent, I got 19 loaves of bread. So these proportional relationships in forms of tables and equations and graphs, we can use that information to solve problems that don't fit in those tables or didn't fit on the graphs. It's all related to proportional thinking to do that kind of problem solving. So that concludes this lesson. Good luck on your assignment.